Welcome back in the third lecture of multiple integration. So, in the previous lecture, I had given the theory on how to find the limits if the limits of integration are not provided. And we have taken two sums where one sum we have considered a vertical strip and another sum we have considered horizontal strip. So in continuation of the lecture today, we will be taking more sums in order to understand the concept very well. So we have taken just two sums. We will continue with the sums, and in the end of the lecture, I will be explaining all the concept once again to memorize it very well, right? So in continuation with the sums that we had taken in the previous lecture, let us continue. Evaluate double integration of x square y square dx dy over a positive quadrant of a circle x square plus y square is equal to 1. So now the region is given to us, curve is given to us. So as we saw in the earlier lecture, procedure I had made you write. Go back to the procedure of the earlier lecture. What was the step 1 of the procedure? First, we draw the curves that are given to us. So let us draw the curve first. So the curve that we draw is, clearly you have a circle with center origin and radius 1. Okay, so this is my origin. This is 1, 0 because the radius is 1 given in the question. This is 0, 1, right? So I have drawn a complete circle, but the question says that it is over a positive quadrant of a circle only. Okay, so the region of our intersection is just the positive quadrant of a circle, right? So the region of our intersection is just a positive quadrant of a circle. And now we will have to consider a strip. As we saw, we may consider a vertical strip or a horizontal strip. So in this case, I am considering a vertical strip. That is a strip parallel to y-axis. Since the strip is parallel to y-axis, you have to find where the strip touches the lower end. So the lower end, clearly this is what? Y is equal to 0. X-axis is also called as y is equal to 0. And the upper end. Now upper end is a circle, equation of a circle. What is the equation of a circle? Given to us, x square plus y square is equal to 1. Since the strip is parallel to y-axis, it is a vertical strip. We need to find the value of y from this curve. So what is the value of y from this curve? Let us simplify the curve and get the value in terms of y. So the value for y is what? Under root of 1 minus x square. So the strip touches the lower end at y is equal to 0, that is x-axis. The strip touches the upper end to the circle. The equation of the circle is given in the question, that is x square plus y square is equal to 1, right? So I find the value of y. So now you know it very well that we are integrating with respect to y first because we have considered a strip parallel to y-axis, right? So we will be integrating with respect to y first. So if we integrate with respect to y first, now let us find the limits of integration. The outer limits will be x is equal to something. Inner limits, because we are integrating with respect to y, the inner limits will be y is equal to something. Now we need to find the inner limits first. What will be the inner limits? The inner limits will be where the strip touches the lower end, that is your lower limit, 0. Where the strip touches the upper end, that is your upper limit, that is under root of 1 minus x square. Right? Now the outer limit. You know that whenever the strip is vertical, it will travel from left to right. So left में x का value 0 है, right में x का value 1 है. So the outer limits are 0 to 1. So these are my limits of integration. So after substituting the limits, this will be my limits of integration. You can also do the same sum by taking the horizontal strip. The answer will come same. Here the strip, interchange of strip will not alter the function. Hence the order of integration is immaterial. But in the most of the problems we have to decide the order. For evaluation the integral is possible. The integration should be easy and convenient, and then it is easy for us to proceed further. Okay, so it should be your choice and your wit to understand or to decide whether to take a vertical strip or horizontal strip. In this sum it is not affecting, but in all sum it won't be same. In some sums the sums get complicated if we take the other strip. So you have to decide at that point which strip to consider. Okay, now let us integrate. As we did in the earlier lecture, let me name it as equation 1. Now we will consider the first integral, the integral in the bracket, as I1. So let I1 is equal to integration 0 to under root 1 minus x square y square dy. Right? Now x square is a constant anyway. We are integrating with respect to y. So that will come outside the integration. So now we will integrate this. So that will be integration of y square will be y cube by 3. And the limits of integration are 0 to under root of 1 minus x square. So after we integrate y, we get y square by 2. Right? So let us substitute the limits of integration. So limits of integration are 1 minus x square, the whole square. Okay, so the integration is y cube by 3. The term was y square. So if I substitute now, I will get 1 minus x square. It is under root. So it is 1 by 2 and this is 3. So the answer is x square is constant as it is, and it is 1 minus x square raised to 3 by 2 upon 3. So now this is the answer for I1. So I will substitute this answer of I1 in my equation number 1. So substituting in my equation number 1, I will get integration I as 0 to 1 x square 1 minus x square raised to 3 by 2 dx. Right? Now we will integrate this. We can use a trigonometric substitution so that integration becomes easier. Let us substitute x as sine theta. There are many other ways to integrate this, but it is your choice how to integrate it. Okay, so this will be cos theta d theta. Now variable has changed, so we need to change the limits of integration as well. Since the variable changes, the limits of integration also changes. So let us write the old limits. What are the old limits? If the variable was x, the limits are 0 to 1. Now the variable is theta. How to find the new limits? These limits we will substitute over here. For example, if I substitute x is equal to 0 over here, sine inverse of 0 will give you the answer for theta. That is 0, correct. Then x is equal to 1. If I substitute x is equal to 1 over here, sine inverse of 1 will give me the new answer for theta, that is pi by 2. So old limits in terms of x were 0 to 1. New limits in terms of theta are 0 to pi by 2. So this is okay. So 1 minute. The earlier part, let me check the earlier part. This was y cube by 3. So this will be 3. Okay, just make a small correction over here. 3 will be carry forward. So this 1 by 3 can come outside the integration. Okay, and now we will substitute. All limits were 0 to 1. But new limits are 0 to pi by 2. So new limits are 0 to pi by 2. Right? So x square, in place of x square I will substitute sine square theta or sine theta the whole square. 1 minus sine square theta raised to 3 by 2. And in place of dx I will substitute cos theta d theta. So this will be cos theta d theta. Right? So if I simplify this further, 0 to pi by 2, this will be sine square theta. You know that 1 minus sine square is cos square. And this will be cos square theta raised to 3 by 2. This 2 will get cancelled. Right? And then cos cube and cos will become cos raised to 4. So this will be sine square theta. And this will be cos raised to 4 theta. Now in the last unit we have studied the reduction formula. So we will apply that reduction formula over here. Okay, and get the answer of the reduction formula. So if I simplify this, my final answer for integration will be okay, this is my final answer of integration. I hope the sum is clear to you, right? So let us continue with the another sum. Now the question is, evaluate integration I as 1 upon x raised to 4 plus y square dx dy over the region y is greater than equal to x square and x is greater than equal to 1. Okay, so this is the region now. So we have studied LPP in 11th standard. So shading will be easier for us. Okay, by using that concept we can see what is the common region of intersection. First let us draw the curve y is equal to x square and x is equal to 1. This greater than equal to part we will use in the shading point of view. Okay, so again what I'll do, I'll take x-axis, I'll take y-axis, right? And now with a different color I'll show you the curves. So y is equal to x square I will draw. You know that it is a parabola. Okay, and then I have to draw a line x is equal to 1. X is equal to a is a line parallel to y-axis. So if this is 1 over here, okay, so this is a line x is equal to 1. Now we need to shade the common region. How do we shade the common region? You know that y is greater than equal to x square. So and x is greater than equal to 1. That means x is equal to 1. That will be y is greater than equal to x square. So what will be the common region in this? The region will be this up till infinity. The region won't stop. Okay, the region is not ending anywhere. The region is up till infinity. Now look at this sum. Here y is equal to x square represents a parabola with y-axis and x is equal to 1 is a line of intersection. So the point of intersection over here is easy for us to determine. right? So if x is equal to 1, obviously y will be 1. It is orally we can do. This point is 1 comma 1, right? Now the equation of the integral, if you look at the equation of the integral, look at the equation 1 upon x raised to 4 plus y square. In this evaluation, if we decide to integrate with respect to x first, we would get x raised to 4 in the denominator, okay? But now with y as a constant, and which is really complicated. So if I take a strip parallel to x-axis in this case, the integration will be more complicated. Instead, if I take a strip parallel to y-axis, the integration becomes simple. So in this case, by our logic, we come to know that integration will be difficult. So I am taking a strip parallel to y-axis, right? Now this strip, you have to check where it touches. The strip is touching here down to the red line, okay? Y is equal to x square. So my lower limit will be y is equal to x square. But up, strip is touching nowhere. Strip is not touching anywhere. So up the limit will be infinity. Again, the strip will travel from left to right. That is, the strip will travel from here, the value is 1, and it will go up like this infinite times. So again the upper limit will be infinity. So considering the vertical strip, the end limits are y is equal to x square to infinity. So now clearly the integration is with respect to y first, because we are taking the strip parallel to y-axis, right? The strip, the limit should be inner limits y is equal to, and outer limit should be x is equal to. So y is equal to what? The strip touches the red line, we can see in the diagram, that is x square. Up strip is touching nowhere, so it is infinity, infinite the strip is, okay? Here x is 1, lower limit, and upper limit is again infinity. So these are my limits of integration, right? Now I will again write this as equation 1 and consider the first integral I1 as x square to infinity 1 upon x raised to 4 plus y square dy. Now you know that when I integrate with respect to y first, my x raised to 4 is a constant term, and you know this formula that if you have this dx upon a square plus x square, we have seen in the integration formula, the answer is tan inverse of x by a. Okay, so we will use that formula over here because now my x raised to 4 is a constant. You can treat that x raised to 4 as a term. So this will be nothing but 1 upon x square tan inverse of y upon x square. X raised to 4 you have, so you can take it as x square. Okay, so x square to infinity are my limits of integration. Okay, so now I will substitute the limits. Remember, we have integrated with respect to y. So the limits should be substituted in y only, right? So the limits will be tan inverse infinity and the lower limit will be x square. So that will be tan inverse of 1, right? So you know it is, the answer will be what? 1 upon x square pi by 2 minus pi by 4. So this is the answer for my I1, right? So now this answer of I1, I will substitute back in my equation number 1. So if I substitute back in equation number 1, I get the limits of integration as 1 to infinity, 1 upon x square pi by 2 minus pi by 4 dx. Okay, now solving this is too simple, it's too easy, right? So this is pi by 4, which is, you can take outside the integration. 1 to infinity can be written as x raised to minus 2 dx. and then integration, you use the formula x raised to n formula. X raised to n is x raised to n plus 1 upon n plus 1, and the limits are infinity. So pi by 4 into that will be minus 1 by x, 1 to infinity. So let me substitute the limits. That will be pi by 4, that will be 1 upon infinity, minus minus will become plus 1. So you know that 1 upon infinity is 0. So my final integration answer will become pi by 4. Okay, this will be my final integration answer. So this was a sum where by our wit we decided that no need to integrate with respect to x first, because that may complicate the sum. Fine. So now let us take another example. Now the example that we are going to take is a bit different. That means the curves are not ready-made. Instead of curves, points are given to us and we need to plot those points as we plot on the graph paper. Okay, so let us take the sum. It's an interesting sum. Evaluate where the region forms the triangle joining the points. So now the region is a triangle that is given, but you don't know we don't know the curves. Usually what happens is when we consider a strip, we have to consider the curve. Here the curves are not given, points are only given. So the points are 0, 1, 1, 1 and 1, 2. Right? So now we'll have to first plot those points on a graph paper and join those curves. Okay, fine. So let us start doing. First let us plot the point. For example, this is x-axis, this is my y-axis, right? So now the points that we require is 0, 0. Next we require this point 1. Next we require this 2. Here also we require 1 and here also we require 2. Now which point I need to plot first? Let me take with a different shade. First let us point 0, 1. Where will be 0, 1? X-axis 0 and y as 1. So 0, 1 will be over here. This point is 0, 1. Right? Now let us plot the next point. 1, 1. 1, 1 is easy. This point will be 1, 1. That is x coordinate 1 and y coordinate 1. Next 1, 2. X-axis 1 and y coordinate as this will be 1, 2. Now the triangle that we need to join, we'll be joining the triangle now. The triangle will be taking this and this point. Okay, let me take a different color for you so then understanding becomes easier. Then this and this point, okay, and then join the third, that is this and this. Clear to you? How did I plot? I plotted 0, 1, I plotted 1, 1, I plotted 1, 2. So now my area of intersection is this triangle that is given to the question. So this triangle I am shading. I need to find the area of intersection. I need to find double integration over this triangle. So now I will consider a strip parallel to x-axis or parallel to y-axis. Okay, that is your choice. Let me take a strip parallel to y-axis only. So now the strip touches, if you look at this, the strip touches this blue line down. But I don't know what line is this called. I don't know the equation of that line. Okay. The strip touches the green line up. But I don't know the equation of that line. Right. So, but this blue line, you know, it is parallel to x-axis. It can be clearly found out. That line is y is equal to 1. Let me name these coordinates. So then for you, explaining to you will be easier. Let this be A, this be B, and this be C. Okay. So now you have to find the line AB. What is the equation of line AB? And also you have to find the equation of the line AC. Right? So now there are many methods where to find the equation of line AB and AC. Depends on your choice what you use. You can do it orally also. Many of you can do it orally because you know that line AB is parallel to x-axis. Clearly it will be y is equal to 1. Okay. But finding line AC will be a bit difficult. So there is a 2-point form that we have studied. Let us revise. In 11th standard, there was a 2-point form that we studied. So somewhere you can write up in the margin. I'll give you the formula. If x1 and y1 and x2 and y2 are the 2 points then by the 2-point form. What is the 2-point form? You remember we did it in 12th standard only. The 2-point form is y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. Okay, so this is my 2-point form. Whenever we have 2 points and you have to find the line, equation of the line, we can use this. Okay, so this is your 11th standard part. We have just recalled it over here. Now we will have to find the equation of the line AB and equation of the line AC. Okay, so equation of the line AB, no need to find by 2-point form because it is oral. Okay, it is a line parallel to x-axis. Okay, so it will be y is equal to A. So A value is what you know. A और B में दिया हुआ है. Value for y is 1. Okay, so the equation of the line AB is y is equal to 1. Orally it is. So line parallel to x-axis is a line y is equal to A. You know this. Okay, and the value of A is, you can find out from here only. The value of A is 1. Value of y is 1 in this case. Right? So equation AB will be a line y is equal to 1. So this equation AB is a line y is equal to 1. Now let us find the equation of the line AC. That we'll do by 2-point form. Suppose okay, the equation of line AC. So let A is what? A is given in the question, it is 0, 1. And C is given, it is 1, 2. Okay. So I will consider these as what? My x1, y1. And this is my x2, y2. So now the formula that I have written here, this 2-point form, I will use this 2-point form and get the equation of the line AC. So let us substitute in 2-point form. What we'll get? Y minus y1, y1 is 1. Then x minus x1, x1 is 0, equal to y2 minus y1, y2 minus y1 upon x2 minus x1. This is what you will get. So let me simplify this equation. Cross multiply. So this is the line, equation of the line AC. So this equation of the line AC I've got as y is equal to x plus 1. So let me write this line as y is equal to x plus 1. Okay, so this line, I'll darken it, which is touching. this line is y is equal to 1 clearly. Okay, and the other line, let me show that by another color. This line is what I found out right now, y is equal to x plus 1. Now I need not find BC right now. BC, when would I found out? When I was taken the horizontal strip. But here I have taken vertical strip. In vertical strip, I just want where the strip touches to the lower end and where it touches the upper end. So lower end is 1 and upper end is x plus 1. So here I have got my inner limits. Now for the outer limits. Outer limits, you know that the strip will travel from left to right. Left, the value is 0 and right, the value is 1. So the outer limits will be 0 to 1. So let us write the limits of integration now. The integrand is x square minus y square. Since we are taking a strip parallel to y-axis, first we will integrate with y first, strip parallel to y-axis, and then with x. Okay, so now writing the limits, the strip touches the lower end. Let me look in the figure. Lower end to 1 and upper end to x plus 1. So lower end to 1 and upper end to x plus 1. And for the outer limits, it is clear, it is 0, 1. So we will solve this integration as we did in the earlier sums, and then we will get the answer of the final integration after we substitute in equation number 1. Okay, so similarly, let me consider, you can do it directly also. If you are convenient doing directly, don't do this I1 business. But if you are not very good at doing inside that integration and then you get confused, so it's always better to do I1, solve that and then substitute back. That causes me no harm actually. Okay, so let me integrate this. After I integrate, this will be x square y. This will be y cube by 3. Okay, so the limits of integration are 1 and x plus 1. So if I substitute the limits of integration, remember we are integrating with respect to y. So we will substitute the limits in y alone. So x term will be as it is. Let me substitute the upper limit first. And then I will substitute the lower limit. Let me substitute y. So minus minus will become plus. Don't make a mistake over here. So this is the answer for I1. Now this answer I will substitute in equation 1 and solving this will give me the final answer. So I will be 0 to 1. This whole answer, whatever I have got, x plus 1 minus x plus 1 the whole cube by 3 minus x square plus 1 by 3 dx. So if I integrate this, before integration, let me open the brackets. So then integration becomes easier. Okay, so this will be x cube. This will be x square. This I am keeping as it is. I am not expanding the terms because I'll have a lot of terms and then it will be a bit complicated for me. Okay, so now let me integrate it one by one. This will be x raised to 4 by 4, x cube by 3. This will be x plus 1 raised to 4 upon 4 and this 3 will give me 12. This will be x cube by 3 and this will be 1 by 3x. So now the limits of integration that I am using is 0 and 1. So let us substitute the upper limit 1. So I'll have 1 by 4. Sorry, this is not minus, this is plus. 1 by 3. This will be what? 2 raised to 4 is 16 by 12. This will be 1 by 3. And x raised to, and this will be plus 1 by 3. Okay, so let me simplify this integration. So the final answer that I'm getting for this is, after simplification, the final answer that I'm getting is minus 2 by 3. Okay. So these were some simple sums based on your limits of integration are not provided. I hope the concept is clear now, and it is quite easy if you are able to draw the curves and find the region of intersection. Okay, thank you.